Welcome to Math with Mrs. Bibb. Today I am going to discuss vertex and standard form of a parabola. Just a quick review as we've been doing this in class. Vertex form is pictured here. Remember your A value, this big arrow is pointing at A. Your A value tells you the direction of opening. We knew that it pointed up if A is greater than 0, which means it's positive, and we knew that it pointed down if A is less than 0, which means it's negative. Then it also tells you the size of your parabola. It is more narrow than the parent function, if A is greater than 1, and really technically I should say the absolute value of A, because the negative sign only has to do with being a reflection across the x-axis pointing up or down. So I really should say the absolute value of A. So you look at A as a positive number when you're thinking about the size. And then it also tells you that it's wider than the parent function if the absolute value of A is between 0 and 1. And then remember, sorry, I have to put my arrow for this one here. Remember, this is your left or right movement. And that is the x-coordinate of your vertex. And then, and of course it's called h, so it's the x-coordinate of vertex. And then the k value is your up or down movement. And that is the y value of your vertex. That's k. So the vertex is hk. In class, remember we talked about it like this. Your vertex is your left or right movement as your x-coordinate and your up or down movement as your y-coordinate. If it's left, then you put a negative. If it's right, you put a positive. If it's up, you put a positive. If it's down, you put a negative. So don't forget that little trick that we did in class. And now your axis of symmetry is x equals h. Whatever that value is in your vertex, x equals whatever this number is. And then the direction that it opens is up if A is positive, and down if A is negative. And then I have an example we'll talk about domain, range, maximum, minimum on that example in the next slide. So that was just a basic overview. Please make sure you have all of that written down. Let me go on to the next slide. So here's vertex form. Quickly, I'll go over this. You have this on your sheet that you're using to take these notes. Most of this is what I have written already. Left or right. Left is positive. Right. Oops, sorry. I goofed that. Negative, positive, positive, negative, which we know this. We've already done it. It opens up if A is positive. It opens down if A is negative. It has a maximum value. If it opens up, it's pointing to positive infinity, and then this point is your minimum value. So if A is greater than 0, then you have a minimum, and it's the y-coordinate of your vertex. Let me highlight to show you these. Oh, that's not a highlighter. This one and this one would be the same, the y-coordinate of the vertex. I'm going to highlight this too. Okay, then for the maximum, that's when it's pointing down. So when it's pointing down, it's coming from negative infinity, so it has a maximum value, and that maximum value is still that y-coordinate of your vertex. And then remember, we discussed the domain is always negative infinity to positive infinity. The range, if it points up, will always be from the y-coordinate of your vertex to positive infinity. And if it points down, it will be from negative infinity to the y-coordinate of your vertex. And please, please note, this is a bracket, this is a parenthesis. This is a parenthesis, this is a bracket. These are parentheses. And I'm hoping that I have this removed from your paper. If not, you can scribble it out as I write it out. We're not going to discuss this in this Algebra 2 class. So I'm whiting out. You can fast forward till I get it all whited out. That's fine. And we're also not going to find the y-intercept. So I'll just get rid of that also. And I'm going to get rid of y-intercept, increasing and decreasing. So you are welcome to fast forward. And now I'm ready to do this problem over here. For this one, my left movement, this is left 1, down 3. So left, whoops, I was going to put 3. Left 1, down 3. That's my vertex. My axis of symmetry is x equals -1. My direction of opening, I look at my A value. Let me highlight that. Look at my A value. If it's positive, it points up. If it's negative, it points down. If it's a reflection across the x-axis, it points down. So I know this one points up. It points up towards positive infinity. So since it points up, this point here is a minimum, not a maximum. It's a minimum, and that minimum value is -3. My domain is from negative infinity to positive infinity, just like we discussed in class. And the range starts at your y-coordinate, -3 to positive infinity. So that's just a quick review of vertex form. Now we'll go on to another form called standard form. Here is standard form of a quadratic. Notice we know this is a quadratic because we have x to the second power, which is that parent function of a quadratic. This is specifically a parabola because remember there are 4 quadratics. We discussed that in class. The 4 quadratics are circle. I'm going to write those down. Circle, parabola, hyperbola, and ellipse. So those are the 4 quadratics. This one is a parabola. All of these have a largest exponent of 2, and we're working with just parabolas. Now, the first thing you have to know about standard form is there aren't any parentheses. When you look at this problem, you do not see parentheses at all. So this is not vertex form, and it is not as easy as vertex form. The first thing that you have to do when you have standard form is you have to name your A value, your B value, and your C value. That's the first thing that you have to do. And I want you to realize that A is the number beside of x squared, and B is the number beside of x, and C is the constant. So I want you to try to get that in your mind. A, B, and C, the red, the blue, and the green, are all numbers. So this is a number. Oops, I don't want to do that in red, so sorry. This is a number, not x squared. Don't include x squared in naming A, B, and C. For the B value, B is a number. Don't include x squared. Excuse me, don't include x. and C is just a number, it will not have a variable. C is a constant. A constant doesn't vary, so it doesn't have a variable. So remember that. Standard form does not include the variables when you're naming A, B, and C. Okay, let's go on to the next. That's going to look very familiar. The only thing that I changed a couple things, but I changed this. This is not Vertex form anymore, this is standard form. If you will pause the video and fill in or write in anything that is not written on your paper, and then once you have done that, if you will continue the video and I'll discuss the things that you may not know yet. Okay, so hopefully you paused and wrote down everything that was written down that was not on your notes paper. Now, the first thing you're going to do when you have standard form is you're going to name A and B and C. Underneath it, you're just going to put A equals, B equals, C equals, and put the actual numbers that belong to each of those. So, what I'm going to do next is I'm going to use a formula. This is a formula you're just going to have to remember, and we'll say it dozens of times in class so that you will know this formula. To find the axis of symmetry, you have to do a math problem. X equals negative B over 2A. Then you fill into this formula the values that you have in the problem above. This negative B thing basically means negative B, or the opposite of B. If this is a positive number, then you write it down as a negative. If this is a negative number, then you write it down as a positive. We'll do that over here in this example. But that's the formula for X equals negative B over 2A. And the next thing I need to tell you is that once you know this value, once you know negative B over 2A, that is the X coordinate of your vertex. You know it now. You know what X is of your vertex. To find Y, you'll see this red highlighting. To find Y, you substitute X into the original equation to find Y. So I'm going to take that value that's highlighted green, I'm going to substitute it in for X and find Y. And now once you have that, you can do everything else because we've done it in class. We went over and over and over the direction of opening, the minimum, the maximum. Nothing changes. Even the fact of your A value, you look at, let me pick another color for highlighter. You look at your A value, that A value. If this is a positive number, if it's greater than 0, then it opens up. If it's less than 0, then it opens down. Now let's do this example. We're going to go through exactly what I just said in the order that we're supposed to do them. We're going to find A equals 2, B equals negative 8, and C equals 1. That's the first thing we're going to do. Let me quickly go back over this again. Remember, A is the number that's beside of X squared. B is the number beside of X, and it's a negative 8. If it's a plus, it's positive 8. And then C is the number that does not have a variable beside of it. I do want to tell you that sometimes B can be 0, and sometimes C can be 0. But A is never 0. A is always a number. But B is sometimes 0, and C is sometimes 0. I'll also give you another hint for the people who are actually listening to this video. I won't write it down. But for the people who are actually listening to this video, and if you're listening, you might want to write this down. Maybe write it down over here. If B is 0, then that's vertex form. And it's so much easier than what we're about to do. So if you're actually listening to my voice or reading the captions, if you have the captions on, then over here in this area, write that if B equals 0, then it's vertex form, and it's easy. It's so much easier than going through all these steps we're about to do. Okay, so back to what we were doing. We are going to find the axis of symmetry first. I know I swapped them over here, but we're going to find the axis of symmetry first. I'm going to use this formula. Okay, so X equals negative B. B is negative 8, so I'm going to put positive 8. over 2 times a. So that's my math problem. Then I'm going to keep my x equals, because remember the axis of symmetry is x equals, and I'm going to multiply. Let me get my little pointer. I'm going to multiply before I divide every single time. Multiply before you divide. So 8 divided by 4, and then divide. X equals 2. That is my axis of symmetry. So now I'm going to put 2 up here. I'm going to grab a highlighter, and I'm going to use red because I'm going to show you what you do. You take this value here up to this original and put 2 everywhere you see x. I'm going to do that at the bottom. Hopefully you have space too. So I'm going to find my vertex. Y equals 2. Instead of x squared, I put 2 squared minus 8 times 2 plus 1. Then I do order of operations. 2 to the second power is 4. Do your exponent first. I don't multiply first. I always do my exponent first. Now I have multiplication, subtraction, multiplication, and addition. I would multiply next. So y equals 8 minus 16 plus 1. And now we add and subtract in order from left to right. 8 minus 16. Different signs, subtract. 16 minus 8. Keep the sign the bigger number, so negative 8. So y equals negative 8 plus 1. Different signs you subtract. 8 minus 1 is 7. Keep the sign the bigger number. So negative 7 is the y-coordinate of the vertex. Now we can carry on and do the rest of this. To find my direction of opening, I look at A. If it's positive, it opens up. If it's negative, it opens down. So this one opens up. Since it opens up, this is the lowest point, which means it's a minimum value. And that minimum value is the y-coordinate of the vertex. Next, the domain. We know the domain is always negative infinity to positive infinity. For my range, it's pointing to positive infinity, so positive infinity goes here, and it begins at negative 7 with a bracket. Don't forget that. And then the y-intercept, that's a new thing. Down here on the bottom right, I don't even know if I've mentioned it yet. The y-intercept is the c value. Look, here's c, here's c. So the y-intercept is 1. That is so easy to do. And that's the first example. Here's another example to find vertex, axis of symmetry, the direction it opens, the maximum or the minimum value, the domain, the range, and the y-intercept of a quadratic in standard form. The first thing that you have to do is you have to find your axis of symmetry. So don't forget that. You have to start with your axis of symmetry. So that's what I'm going to do. I'm going to use that formula, x equals negative b over 2a. Remember, a is negative 5, b is negative 20, and c is negative 3. Whoops, and I put 30. Oopsie. Now, x equals negative b. So negative 20 would be positive 20 over 2 times a, which is negative 5. So x equals 20 divided by negative 10. X equals negative 2 is my axis of symmetry. For my vertex, I know that negative 2 is the x-coordinate of my vertex. And now to find the y-coordinate of my vertex, I substitute, let me go get a highlighter. I substitute negative 2 in for x. Everywhere there's an x, you put negative 2. So I'm going to do that now. Y equals negative 5 times negative 2 squared minus 20 times negative 2 minus 3. Then I'm going to do order of operations. I'm going to do my exponent first. So negative 2 squared is positive 4. Negative 20 times negative 2 is positive 40 minus 3.
Then I'm going to multiply. That would be negative 20 plus 40 minus 3. And I'll add and subtract in order from left to right. So negative 20 plus 40 is 20, and 20 minus 3 is 17. So the vertex is negative 2, positive 17. Now the direction it opens is just like it was when we were doing vertex form. Your A value tells you your direction. A is negative, so that means that the direction is down. Since it points down, then we know this is a maximum value. So I'm going to scribble out minimum, and so maximum is visible. And remember, the maximum value is the y-coordinate of your vertex. So the maximum is 17. The domain is negative infinity to positive infinity. The range is from negative infinity to positive 17. And then the y-intercept is your c value, so that is negative 3. I'll save these examples for us to do together in class. So if you will write them down, and then in the classroom, I'll go over these 3 separate examples. So just write those down, include them in your notes.